Hi folks, I hope you're doing well today. In this video I would like to discuss nonlinear inequalities. Hopefully you've gotten some lessons on graphing linear inequalities. If not, please go back and do that first. And when we talk about nonlinear inequality, it really is the same idea, but you're dealing with lines that are not straight. So that's not linear. I know this inequality, first of all, let's talk about it. How do I know it's an inequality? Because of the greater than. Remember, inequalities are greater than, less than, greater than or equal to, or less than or equal to. How do I know it's nonlinear? In other words, not a straight line. Because this particular polynomial is an x squared. And what do x squareds graph? Well, they graph parabolas, right? So if you need to go back and watch videos on parabolas or redo some homework on parabolas, you're going to have to be able to graph a parabola in this section. Quite a few of them, as a matter of fact. So let's get this parabola graphed. Now, this is not what we call standard form for a parabola. Remember, that's if you have a times x minus h squared plus k. And in that form, you can easily read the vertex. It is hk. That's okay if it's not in that form, because remember, we have another way of handling this. The vertex, or the h value, or we call it x, is equal to negative b over 2a. Now, a, b, and c is like for the quadratic formula. So in this case, my a is negative 1, my b is the coefficient of x, which is 4, and my c value is negative 1. So when I plug in those values, and notice this is just part of the quadratic formula. It's the part without the plus or minus square root. Okay, so negative b over 2a. You've got negative, my b is 4 over 2, and my a is negative 1. When I reduce that, that gives me a positive 2. You see that? The negatives cancel. 4 divided by 2 times 1 is 2. So that's my x value of the vertex. How do I find y? I go back and substitute my x value into the function. Okay, so think about this as a function. It's an inequality, but right now it's a function. So we're going to plug 2 into that function. So I have negative 2 squared plus, yes, 4 times 2 minus 1. When I simplify that, I've got negative 4 plus 8 minus 1. Negative 4 left to right. Negative 4 plus 8 is 4. 4 minus 1 is 3. So I know my vertex is at 2, 3. Okay, so I'm going to go over to 2, 3 and plot that point. There we go. There's 2, 3. Now the next issue is, does this parabola open upward or downward? That's the question. How do I know? Okay, first of all, I know that the thing opens downward. Why? Because my a is negative. Anytime your a value or your leading coefficient is negative, whether it's out front and needs to be multiplied in, or in this case, it's all expanded, my leading coefficient is negative, therefore I'm opening downward. Next question, has it been stretched? It has not, because your a value, the absolute value of a is positive 1. The negative is the reflection. So we know it opens downward, but the leading coefficient is a 1. It's not stretched or compressed for that matter. Now what does that tell me? That tells me it opens down, and on either side of the vertex, I'm just down 1. If it's not stretched, that's how a parabola is shaped. Now you could plot more points if you want to, but roughly, this is what I'm dealing with. Okay? Now my next issue, I'm going to have to erase, because this gets into the inequality part. Am I supposed to do a solid line, or am I supposed to graph a dashed line? Now again, from watching previous videos or having some lessons on graphing linear inequalities, remember, solid lines come when you have a greater than or equal to, or a less than or equal to. Dashed lines are used when you have a greater than or a less than. So my parabola over here should have been a dashed line in this case. So let me get rid of my parabola. There she goes. And now I'm going to do a dashed line instead. So this is dashed, keeping in mind it's not perfect. But when you graph these, usually on the computer, you only need 3 points, so there's my 3 points. Finally, I'm at the shading stage. What do I shade? Now, you can look at the original problem. It says y is greater than our parabola. Now, what y's are bigger than my parabola? So you're talking about everything up here, right? So I can just shade there. That means all of this, all the way to the dashed line, but not including the dashed line of my parabola, is shaded. Now, if you've watched the other videos or heard me lecture on the idea of testing points, that works as well. So you could test something underneath the curve of the parabola or something outside the curve of the parabola. Okay? Now 0, 0 looks like a good one to test, but it's kind of hard to tell if my parabola goes through that. It doesn't, but let's pick something that's more clear. Now I've got it shaded. I'm certain it's shaded right, but we're just going to test a point. So for example, the point 0, 4. Because I've got it shaded, you know, it's sitting right here, okay, because I have that point shaded, then it should make this inequality true. Let's check it out. So 4 is my y value, is 4 greater than negative 0 squared plus 4 times 0 minus 1. And that says 4 is greater than 0 plus 0 minus 1 is minus 1. Is that true? Sure is. That means I've shaded in the right place. So when you're dealing with a parabola, you're either only shading outside of the parabola or underneath the parabola. So there we go. We've got that one done. Let's try another one. All right, now for this problem, you notice we have a system. So how do you know you have a system? When you have more than one equation, or in this case, more than one inequality. This is called a system of inequalities. Now, the next question, is it linear or is it not linear? Well, notice the first inequality has an x squared in it. So that's nonlinear. That is not a straight line. But look, the second inequality is y to the first and x to the first. That guy's a straight line. So we have a parabola because of the x squared along with a straight line. Now, how are we going to handle this? Well, if you look at the first inequality, you may recognize that. We just did that problem. So if you recall, let me flip back. Look, we had a vertex of 2, 3. Okay, and then the parabola opened downward. Let's review that real quick. And it was a dashed line because of the greater than. Okay, so let's get that back on the page. So again, the vertex was 2, 3. Remember how we found that was simply by using the formula negative b over 2a. It opened downward and it was not stretched. So that means you can go on either side of the inequality and go one away in the down direction. It was a dashed line. It bothers me a little bit that I didn't know where the y-intercept was. So if you plug in 0, you notice you get negative 1. So that's this point here. On the last page, I was a little bit off on that graph. I didn't worry about it, but now it's bothered me a little bit. And remember, we shaded above the parabola because it says y is greater than the parabola. So this is the first inequality shaded. And this is just information, again, from the previous problem. I'm just recopying and kind of re-explaining what I did. I'm sorry the shading takes so long. Takes you a little while too, I know. There we go, shaded. Now let's look at our second inequality. And notice we have a straight line. How do I know? Again, y to the first and x to the first. So how do I graph this? Well, remember, this is in the form of y equals mx plus b. Okay, my m is the value I'm multiplying times the x value. So in our case, our m is 1/2. What is m? Slope. That means we would go up 1 and to the right 2 from my b value, which is my y-intercept. What's my y-intercept? It's 0, right? That's like a plus 0 sitting out there. So here I go, this time in blue. My y-intercept is 0, which looks like it intercepts the parabola, but it doesn't. Remember, that y-intercept for the parabola is at negative 1. And I rise 1 and run 2. So there's my next point. I rise 1 and run 2. There's another point. I continue this all day long if you want to. I could also go down 1 and left 2. That would imply they're both negative, which is still a positive 1/2. So down 1, left 2, do it again, down 1, left 2. Okay, now do I do a solid or do I do a dashed line for my second inequality? Notice it's got greater than or equal to, therefore a solid line is what we need. So I'm going to connect these dots, connect my points right there with a solid line, and now I've got to figure out what to shade. Now it says y is greater than or equal to 1/2. That means my y's, what I shade is above the line, because y is up and down, right? And if y is greater than that, it's above the line. You could also test a point. Now you can't test 0, 0, right? Test something above the line. For example, let's test in green 2, 0. We're just going to test 2, 0, and again into the second equation. Is 0 greater than or equal to 1/2 times 2? Is 0 greater than or equal to 1? Now you notice that's a false statement, but remember where the point 2, 0 is. 2, 0 is right here. I might have implied that it was up here, and I think that's the one I meant to grab, but that's 0, 2. 2, 0 is right here in white, and since that's a false statement, I do not shade the side with 2, 0 on it. I shade the side, just like we said, where y is above the line. Y is greater than or equal to the line. So we're talking about above the line, and when I shade that in, there we go, I'm shading in everything above my solid blue line, which definitely takes a minute. The good news is when you do this in homework, if you do this homework online, shading is pretty easy. You just slide a button to the way you want it to look, and poof, it's done for you. There we go. Now, what's my answer? If you don't see color well, you're not going to follow what I'm about to say, but my answer is where the two colors intersect, which is actually green in this case. So if you see the green, okay, then that's my intersection. Now, I'm going to highlight this in black so you can see. So my final answer in black, and it's dashed on the parabola, goes up. All of that is shaded in both colors. Okay, notice it doesn't go inside the parabola here. It goes dashed around the parabola. And that's the final answer for the inequality. It's what's shaded in both colors. Okay, let's try another one. So directions, graph and shade the following inequality. So we have x squared plus y is less than 1. Now, is that linear or nonlinear? Now, at the top of the title, I say nonlinear inequality, but that doesn't mean anything. How do you know this is linear or nonlinear? Well, I know because of the x squared. Remember, anytime you have your y or x raised to a power, you're not dealing with a straight line anymore, unless something can be canceled or simplified. But this is not the case. Nothing cancels or simplifies here. Now, how am I going to graph this? It looks a little weird, right? Well, here's my advice. If you can isolate the y, you should. That will help you out. So what am I going to do? I'm going to subtract the x squared to the other side. So I could write this as y is less than. When I move that x squared to that side, it changes the sign, right? So it's positive x squared here. I'm going to make it negative x squared. And the plus 1 that's already on the right remains. This is what we would rather graph. Okay? So this is more like function notation. Remember, this is like f of x over here for y. Now, what is this shape? It's a parabola because it's x squared. Is it in standard form? Well, it is, actually. I know that this parabola opens upside down, or it opens downward. That's the way I said it earlier. And the plus 1 means it's been moved up 1. Now, if you didn't catch that, okay, what if you're thinking vertex instead? That's fine. So x is equal to negative b over 2a, right? My b, again, you're looking at the rectangled one here. There is no b value, right? This is a. B is the value times the x, and c is the constant. So it'd be negative 0 over 2 times negative 1, which is just 0. I plug that 0 in. Y equals negative 0 squared plus 1, and I get 1. So the vertex is 0, 1, or the same as saying the parabola has been moved up 1. So here we are at 0, 1. Remember, it's upside down. Has it been stretched or compressed? No, it hasn't. How do I know that? Because my leading coefficient is just a 1. Remember, the negative is the upside down, but the 1 part means it has not been stretched out. Well, if my parabola hasn't been stretched, that means on either side of the vertex, 1 away, I'm down 1. Now, if this opened upward, I'd be up 1. Now, next thing, do I do solid or do I do a dashed line? Okay, and it is a dashed line. Why do we know? Because this is strictly less than. There is no equal to. So I connect my dots with a dashed line. So there's my dashed parabola. And what that means is no answers that make this inequality true lie on the parabola line. Now the next question is, what part do I shade? It says y is less than my parabola. So if I shade values less than my parabola, it means under my parabola, right? So if I shade under my parabola, it's going to be right here. It goes right to the dashed line, but doesn't include it. So look, if you'll look, it looks like I'm writing right on top of the dashed line, and I sort of am, but it really doesn't include it. Okay, and it goes down forever, even though my parabola stopped and I put arrows on it, but that still goes down in that fashion forever. So there it is, shaded. Now, if you didn't really trust that you analyzed that correctly, your shading, test a point. So notice 0, 0 is not on my parabola, so let's test 0, 0. So I'm just going to plug it in. My inequalities is 0 less than negative 1 times 0 squared plus 1. Well, that's just 0. So 0 less than 1. That is true. That means we shaded the correct part, which 0, 0 is right there, right? All right. Now, in this case, I have a system of of inequalities. Linear or nonlinear? How do you know? Well, the first one is nonlinear because of the x squared. The second inequality that's listed is actually linear because it's y to the first power and x to the first power. Now, the first one ought to be familiar to you. We just graphed that. So that is y is less than. Remember, we wrote that as negative x squared plus 1. What did that give us? A parabola that was up at 0, 1, not stretched out, which means either point is 1 away from the vertex, and it was a dashed line going downward. How do we know this parabola was pointing downward? Because of the negative leading coefficient. That's why it's pointing downward. And finally, we shaded under the parabola. So we know that all of this part is shaded y under because it says y is less than the parabola. Or you could test a point. You could test a point under the parabola and test a point outside of the parabola. There we go. First one just reshaded, just like we did the last problem. Now we're going to deal with this straight line. Y is greater than 2x. It's going to be dashed as well. Why? Because there's no equal to here. You can think about this in terms of y equals mx plus b. What's my b value? It's 0. What's my m value? 2. So my y-intercept is 0. So that is 0, 0. I put it there in blue. No, it's hard to see. And my slope is 2 over 1. So I'm going to rise up 2 and run 1. So up 2, run 1. Up 2, run 1. Up 2, run 1. You could also go the opposite. You could go down 2 and left 1. That's really saying negative 2 over negative 1, which gives you a positive 2. Now I'm connecting my dots with my straight dashed line. Now I've got to determine what side do I shade, okay? Now it says y is bigger than 2x, so in my mind that's above the line, because y is bigger than the line is above the line. Now if you didn't believe that, you could test a point not on the line, for example 0, 4 up here. Okay, so is 4 greater than 2 times 0? This is just a test. Again, a test of the point 0, 4. And that is true, right? So that means I do shade above the line. So if you feel like you need to test a point, you can. Or if you're pretty good at saying, oh, well, that just means y is above the line. I've got this. Now here's what's weird on my shading. I just noticed this. I don't know why it's true. but for some reason I cannot shade over the green with my blue. I haven't the slightest idea why, but it won't let me do it. Okay, so I'm also going to shade this like this, okay? And I want you to get the impression it's outside of the parabola because part of this intersects. Now the question is, what is shaded both colors? Remember, the answer is what shaded both colors. So I'm going to play with a different color like this crazy pink and try to get in there and shade the answer. And look at there, it came out with some wild blue. That's my answer. That's what shaded both colors. So you kind of grabbing a hold of this. I can go ahead and tell you, if you're not good at graphing straight lines and you're not good at graphing parabolas, this is going to be a miserable section. So please make sure you're understanding how I'm graphing these. And if you have to go back and help yourself out a little bit and practice graphing parabolas, please do. Okay, I have a couple more problems where we're graphing all the way through on our own, and then I want to show you something different. Same topic, just a different type of question. So in this question it says x squared plus y is less than -5. First of all, that's an inequality, right? Because it's got a less than in it. Is it linear? Is it a straight line? Is it not a straight line? And you know it's not because of the x squared, okay? And we like to get those where there's y on one side, just like a straight line, and everything else is on the other side. And we can do that by subtracting the x squared to the other side. So really what I'm dealing with is y is less than x squared minus 5. Now, oh, negative x squared. I almost messed that thing up, right? So when I move the positive x squared over, it made it negative. So tell me about this parabola. The negative means it opens downward, right? There is no x term, which means this thing has not been moved left or right. It's been moved down 5. Okay, so this is down as in upside down, and this is down 5. So let's do that. We move our parabola down 5. It's down here at -5, and it opens upside down. Okay, now what if you didn't see that? What if you're all about calculating the vertex? That's okay, because remember it's negative b over 2a. So negative b, there is no b. Remember, b is the value times x. There is no x, so it's -0 over 2 times -1, which is 0. I plug 0 into that function, and my y value is -5. So 0, -5, again, is my vertex. That's what we have here. Now, how do I know it opens downward again? Because of the negative times the x squared, or the negative a value. And I know it's not stretched because my coefficient is just a 1 in front of here. And if you're not stretched out, then, and you're opening downward, you just go down 1 on each side of the vertex, 1 away from the vertex. Are we talking solid, or are we talking dashed? Okay, well notice, it's just plain old less than. So we're talking a dashed line. And I do my dashed parabola. There it is. Finally, I shade. Do I shade above or shade below? Notice it says y is less than my parabola. So to get y is less than my parabola, we're talking underneath the parabola. So underneath my parabola is this part right here. Now, what if you feel uncomfortable with that underneath part? Pick a point to test. Like, for example, 0, 0 is not underneath my parabola. If I plug it into my inequality, right here, original 0 squared plus 0, is that less than -5? That's not true, right? That's why I don't have it shaded. Okay? If it were true, then I should have shaded above. So that one is completely handled. Let's turn that into a system. Alright, so here's our problem in system form. So notice the top equation, x squared plus y is less than -5, is the problem that we just did. We wrote it as y is less than -x squared minus 5. It's a parabola that's upside down, and it's been moved down 5. And there it is. It is with a dashed line because there's no equal to there. Okay, so I went ahead and recopied it. It spared you the gory details of me regraphing it. Now what I want to do is graph my second inequality. Now tell me about that one. It's a y to the first and an x to the first. So what do we know? It's a straight line. Well, straight lines are of the form y equals mx plus b, correct? So my b value is 10. So that means my y-intercept is way up here at 10. I made a mark. And my slope is 5 over 1, which means I count up 5 and write 1. But do I really want to do that? Well, no, because I fall right off my graph, right? Is it okay to go down 5 and left 1? Sure it is, because negative 5 divided by negative 1 is still positive 5. So that's what I'm going to do. I'm going to count down 5. Don't start where you are. Start counting. That's 0. 1, 2, 3, 4, 5, and left 1. Try it again. 1, 2, 3, 4, 5, and left 1. There's our x-intercept. And then 1, 2, 3, 4, 5, left 1. Now, do we want dashed, or do we want a solid line? How do we know? Well, we want a dashed line, and it's because there's no equal to there. So I'm going to graph in blue, connecting my dots with a big linear, meaning straight line, dashed line. Next question, do I shade on the right side of that line, or do I shade on the left side of that line? Well, it says y is bigger than that line. And it's hard to think about that, but the y's that are bigger than that line are on the left side. Now, if you didn't see that, just test a point. So 0, 0 is clearly not on that line, so I'm going to test 0, 0. What do I mean by test? Take 0, 0 and plug it in your original inequality. And we're only looking at the second one. We've already got the first one shaded. So 0 is greater than 5 times 0 plus 10. This says 0 is greater than 10. Is that true? Definitely not. That means I don't shade the side with 0, 0. I shade the other side. So let's shade the other side. And this is what we have, right? Remember, my answer is what's shaded for both. What is shaded for both? None of them, right? There is no solution to this inequality. This is a big Okay, it's shaded properly. We're talking about under the parabola. Now, actually, that's not true. Let's back up. Forgive me, I'm not thinking about this properly. Because you know what? Eventually, watch this. This is just kind of a weird graph. Eventually, this guy, if I can get my colors right, goes down like this way forever. Do you agree that those are going to cross each other at some point? So way down here, off my page, these will cross each other. Now, when you're doing this on homework, it's going to show up. So don't fret, don't worry about, oh no. But this continues in this direction, right? These are eventually going to cross each other way further down. We could even find out where they cross each other. Because all we'd have to do is take this 5x plus 10 and plug it in for that y right there. Just see where they cross. And then we would know that the blue and the orange would overlap each other. The good news is this homework, and I'm not going to get into those kind of details. You can certainly do it, but it doesn't ask you to go that far with it, so I'm not going to ask you to go that far with it either. Okay, so when I lied when I said they don't cross. They don't cross in my picture, but they will eventually cross each other. They have to, because that parabola keeps going out and further out, as you can imagine, but this straight line is in the same pattern, so they're going to intersect. And where they intersect, the shading will intersect as well. Good problem. I'm glad we ran into that. Okay, folks, this may be overkill, but I have one more of these where we talk about graphing one by itself, and then we turn it into a system by putting another graph with it. So let's do that. We're supposed to shade y is bigger than x squared minus 6x plus 9. So we know this is a parabola, right? How does it open? Does it open upward or downward? It opens upward. Finally, we have one that opens like a normal parabola. Okay, upward, the U shape. Now, what does it look like? Well, I need the vertex. So now I'm looking for a vertex. To find a vertex, we can use the formula x equals negative b over 2a, because I can't tell if it's moved left, right, or up or down in the form that it's in. So negative b, that'd be negative of a negative 6. There's my b right there, over 2. My a is 1. That gives me 6 over 2, which is 3. So the x value of my vertex is 3. How do I find the y value? Plug that in. 3 squared minus 6 times 3 plus 9. 3 squared is 9. 9 minus 18 is negative 9 plus 9 is 0. Let me check that again. So I've got 9 minus 18 plus 9. Yep, that's still 0. Okay, so 3, 0 is my vertex. So I go over to 3, 0. Remember, we said that this parabola opens upward, and it's not stretched. Remember, we've got a 1 right here in front of my x squared, which means it's not stretched at all, which means that my next points are on each side of the vertex, just up 1. So up 1 at 2 and up 1 at 4. Do I use a solid or a dashed line? This is a dashed line problem because of the greater than. Okay, so here's a rough version of my parabola. It crosses up here at 9. I did kind of a lousy job. Let me fix this. So it crosses up here at 9. How did I know that? Well, if you plug 0 in, 0 squared minus 6 times 0 plus 9 is 9. So 0, 9 is on the graph. Okay? Now, do I shade inside the U or outside of the U? Well, it says Y is bigger than my parabola. So that's inside the U. If you don't trust that, pick a point inside the U and test it. For example, 3, 4, right there. If I plug 4 and 3 over here, 3 squared is 9 minus 18. That's 0. And 4 is greater than 0. So it's true. Okay, so I want to shade in that side. Let's do it in the purple. Purple highlighter is bright. Here we go. Remember the dashed lines. Should have made those darker. The dashed lines are not part of the shading. It goes right up into the dashed lines, but doesn't include it. Okay, so let's get my dashed lines back. I'll make a big deal out of it. Arrows on the end. There we go. So that is my parabola shaded. Okay, now let's turn that into a system. All right, so now we have a system. If you'll notice, the first inequality, y is greater than x squared minus 6x plus 9, has been regraphed. We did that on the previous page. It was prettier on the previous page, but that'll be okay. Now let's look at the second inequality. I've got y is less than negative x squared plus 6x minus 5. Now, is that a straight line? Nope. That's a parabola as well, right? Because of the x squared. It is dashed. Okay, so we're going to do this one as a dashed line as well. We need to know the vertex of this parabola. Remember, that's negative b over 2a. So that's negative. My b is 6 over 2. My a is negative 1. So it's negative 6 divided by negative 2, which is positive 3. I plug 3 into that function. So I get negative 9 plus 18 minus 5. That's going to be 9 minus 5 is 4. So 3, 4 is my vertex. So I go to 3, 4. There it is. That's my vertex. Now, do I do a solid or a dashed line? Well, we know we do a dashed line. Why do we know? Because there's no equal to there with that less than sign. Has it been stretched? No, it hasn't been stretched because there's a 1 in front of that x squared. But does it open upward or downward? It opens downward because of the negative x squared. Okay, so not stretched, which means I go down 1 on each side of the vertex, and then I do a rough sketch of my parabola. There we are. Now the next question is, where do I shade? Okay, it says y is less than my parabola. So less than means underneath the curve. Okay, another way to think about that is just plug in a point. For example, 3, 0 is under my curve. I could test 3, 0. So 0 is my y value. Negative 3 squared plus 6 times 3 minus 5. Okay, so that's going to give me negative 9 plus 18 minus 5. And 0 is less than that because that's going to be negative 9 plus 18 is 9 minus 5 is 4. 0 is less than 4. So that means we shade underneath the parabola. So again, if you're not good at analyzing it or looking at it and go, oh, I just shade under it or above it, then just plug a point either under the parabola or outside of the parabola. If you get a true statement, that's where you shade. So in green, I'm going to attempt to shade good news is the highlighter worked this time. I really like the purple and the green together because that shows the answer is the black part. It's where both of them are shaded. So that's the last system that I wanted to shade for you and do all the graphing that way. Now we're going to do the opposite. Now I'm going to give you a line and you tell me what the system is. This is going to be fun. Okay, so what do you think about this? I have a line here for you, or it might be a curve, whatever the problem is, and now you're supposed to write the inequality that's shaded. Now the first thing we know, this is a straight line, right? So straight lines think y equals mx plus b. This is a skill you should already have, but I do understand if you don't know how to do this. What's the b value? Well, it's where it crosses the y-axis, right? What's the m? Well, my advice to find m is to find a point that goes through a grid line. For example, right here. How do I get there? Now remember, every line here, be careful, is not a whole number. This is 3 right here, okay? So this is not 4, 3, 2, 1, right? This is 4, this is 2, so there's 3 in the middle. So I'm counting down 2 and right 2. Okay, that's 1 right there. So down 2, right 2. So down 2, right 2 means my slope is -1. Did you catch that? So again, to get to another point, I counted down 1, 2, and right 1, 2. Now, if these extra grid lines are bothering you, I apologize. But it has halves marked. But you see, this is 1 right here, 2, this is 3, this is 1, 2, 3. Be careful about that. So that means my equation of the line is y equals -1x. And remember, my b value is 4. So plus 4. Notice that's a solid line. So since it's solid, then you either have a greater than or equal to or a less than or equal to. We don't know which. Finally, what do we put? Is this side, our y's are below the line, right? So that our y's are less than the line. So that's going to be y is less than or equal to -x plus 4. Now you're thinking backwards, right? It's a little harder to do, but since we're below the line, that means our y's are less than the line. Up on the other side, had we shaded the top half up here, that would be y's are bigger or greater than the line. Again, the equal to part is because it's filled in. Okay, let's try another one of these problems. Now this is clearly not a straight line, it's a parabola, right? How would you describe this parabola? It is a parabola. It's not shifted left or right at all, right? It's just moved up 2. Now we've learned how to write these equations. What is a parabola shifted up to? That would be y equals x squared plus 2. We don't add or subtract anything to the x because it wasn't moved left or right. Does this parabola open upward or downward? Well, it opens upward, right? Which means there's a positive 1 in front of the x squared. So we're good. That's a parabola moved up 2. Now, are the y's bigger than our line or are the y's smaller than our line? Bigger than our line is shaded inside. Smaller than our line is outside, out here. So this is y is greater than. There's no equal to because it's dashed. Okay, so just y is greater than x squared plus 2. That is our shaded inequality. Again, it takes practice. Now check out this problem. If you recall, that's the same two that we just looked at, but put together. So our system here is, it doesn't matter which one you put first. I'm just going to put the parabola first. Remember, that was y is greater than. That parabola was shifted up 2. The greater than is because it's shaded above the line. And it was a parabola moved up 2. Okay? The blue line was a straight line, and that was y is less than or equal to. And remember that line, y equals mx plus b, the m was -1 because we were down 2, right 2. So that was negative 1x, and the y-intercept is up here at 4, so plus 4. And that's just a recap of the two that we did. And what it does is it gives us the final answer is just simply the stuff that shaded both colors that I'm reshading here in green. The solid line means that's included as part of your answer, whereas the dashed line means it goes right up to the dashes, but then it stops. So any ordered pair that's in that green area will make both of these inequalities true. Okay, I've got 2 more of these systems problems for you, and then we will call this video complete. Now let's look at the blue first. Let's look at our parabola. Now how would you describe that parabola in the blue? Okay, well, I would describe it as a parabola shifted right 2, so notice that's 2, and it opens upward. You agree with that? Okay, and of course it's dashed. All right, so first of all, right 2. That means we subtract 2 inside the function. Remember, that's how you move right 2. Notice it hasn't been moved up at all. It's just plain old parabola that normally looks like this, been moved right 2. That's it. So that is y equals x minus 2 squared. But we've shaded below the y values. We've shaded below the line. So that means y is less than x minus 2 squared. Now another way to write that is usually in the homework they don't leave it like this. So I would have to multiply that out. Y is x minus 2 times x minus 2. You know how to do this. X times x is x squared minus 2x. There's another minus 2x, and negative 2 times negative 2 is plus 4. So that would be y is less than x squared minus 4x plus 4. That is more than likely how you're going to see that one. Okay, now I didn't leave myself enough room, but let's look at the reddish colored graph. Now we know that's another parabola. Okay, so the red guy is another x squared parabola. How would you say it's moved? I say it's been moved right 4 and up 4. So right 4, up 4. What else is going on? Well, it's upside down, right? So we put that in standard form. I'm going to go to the top of the page. That would be y. I don't know if it's greater than, less than. I don't know any of that yet. Let's deal with that later. Okay. We have a negative because it's upside down, parentheses. To move that thing right 4, we do x minus 4, the square on the outside, and to move it up 4, I put a plus 4 outside the square. So there it is. Now notice it's shaded below the curve. So that's another less than, but since it's a solid line, it's a less than or equal to. Now again, you're probably not going to have this choice as your answer. I need to multiply all that out. So here I go. So I have y is less than or equal to the negative. I'm going to leave alone for now. And I'm going to do x minus 4 times x minus 4. And then at the end, I'm going to add 4. So that's less than or equal to negative. Now, x times x is x squared. X times negative 4 is negative 4x. I have another negative 4x. Negative 4 times negative 4 is plus 16. And then plus 4. Now, if I'm losing you on that algebra, pause it. Work this out yourself, and you're going to go, oh, that's all she's doing. Okay? All right, so y is less than or equal to negative out front. Now, x squared, negative 4x minus 4x is minus 8x plus 16 plus 4. What's with these parentheses? Remember, the negative applies to what's in parentheses. So I have to work this part out first. Then distribute that negative inside. And finally, that's what I'm about to do. I'm going to distribute that negative inside. So that's y is less than or equal to. Now that's negative x squared plus 8x minus 16 plus 4. So finally I have y is less than or equal to negative x squared plus 8x, and negative 16 plus 4 is negative 12. So this guy and this guy right here are my final answer. Now how I'm supposed to write that, well, it would be nice if I didn't have all this mess, but I do, so I'm going to erase a little bit so you can see the final answer. Looking neat. And we don't need all this scratch work anymore. You've got all that. If you don't, just rewind. Okay, so final answer. Oh, there it is. Okay, is going to be y is less than, this is the blue one, x squared minus 4x plus 4. And on the other hand, y is less than or equal to negative x squared plus 8x minus 12. And that is my system. And you do have homework problems like that.